Hello everyone, welcome back to another video. So today we will discuss solutions for weekly contest 389, and I was able to solve only first three problems. Fourth problem seems too difficult for me, and I solved first three problems in approximately 10 minutes. Then I tried D for a lot time. Now in D, basically it has complex implementation, and I was trying it for some time and I couldn't do it. So we will only discuss solutions for first three problems. And if you are specifically watching the video for fourth editorial fourth problem, you can just skip the video. So let's just move on. Start with first question. So first question has a simple problem statement. So in this we are given a string and we have to find any substring of length 2 such that it is also present in reverse of s. So what we can do is let's start with first test case. We are given string as Leetcode, Leetcode, but if the substring of length 2, which is EE, from first index and second index, if we reverse this string also, we can get that same substring in reverse order, in reverse string also. So here answer is true. Similarly, in second test case, we are given a string ABCBA. Now all the substrings of length to AB, BC, CB also are present in AB when we reverse the string. Similarly, in third case, we are given ABCD, and there is no such substring of length 2 which is present in S but not present in, which is there is no substring which is present in S and also present in reverse of S. So here what we can do is, for example, let's say I have a string A, B, C, D, A. Now I will the constraints are very low, so what I will do, I will calculate all the substrings of length 2 by iterating from 0 to n minus 1. N is the length of substring, and map the frequency of each of the substring, and while also I will take the reverse form of substring. So here for all the substrings of length 2 in original string here will be AB, BC, CB and BA, while in reverse string it will be BA, CB, BC and AB. If you see the relation between this, it is just reverse of all the substrings of length 2 in original string, and so I can just iterate in one for loop and take all the occurrences of such substrings, and if I have found a string more than one, I will just return true. So in first I'm calculating the substring of length 2 in original string, and I'm incrementing the frequency of that string. Similarly, I'm calculating the finding the reverse of that string, and again incrementing the what we can say frequency of that string, and I'm finally just iterating over map, and if I found a substring which has frequency greater than equal to 2, I will just return true, else I will just return false. So this was first question. Let's move on to second question. Was also pretty simple. So we are given a string of length s, a string s, and also given a character c. Now we have to return total number of substrings of s that start and end with c. So for example, here we are given A, B, A, D, A, and we have to just find return. We are also given character A. We have to return total number of substrings which starts with A and ends with A. So uh, this this seems a pretty simple combinatorics problem if you have some previous knowledge of combinatorics. Now in this let's say string A, B, A, B and A, we have uh, three indexes where the character at those index is equal to C. So here let's say we have those three indexes are 135 in one based indexing. Now for a substring which starts with A and ends with A, so the number of such substrings will be such that 1 comma 1, 1 comma 3, 1 comma 5. Similarly for 3, 3 comma 5 and 3 comma 3 and 5 comma 5. So if you understand, for this one I have three options, one itself and all the remaining elements. Similarly for these three I have two options, one itself and the elements to its right. Similarly for this 5 there is only one option, that is one itself. So here answer comes out to be 3 into 4 by 2. So we can make a formula that such that if there are CNT number of occurrences of character C in whole string, our answer comes out to be CNT into CNT plus 1 by 2. And the proof of this is, let's say we have n elements, n occurrences of each character. For the first occurrence of that character I have n options. Similarly for second occurrence of that character I have n minus 1 operations. This will repeat until the last occurrence which will have only one such substring, that is itself, which starts with that character and ends with itself. So this sum is equal to n into n plus 1 by 2. So this is a pretty standard mathematical formula. So sum of first n elements is equal to n into n plus 1 by 2. So I use that logic, and you can also use implement this formula directly, or you can just use this kind of logic where I am iterating from right side to left side, and I am calculating the total number of elements which are occurred at previously, means which are present at right side and which are also equal to C. So for example, if I found let's say this A B A B A. Now for this I have only one, this is the first occurrence of A, so I will increment answer by 1. Now for this, when I come to this element, I have I have already visited one of the occurrence of A plus this occurrence, so I will increment 2 here. Similarly for this I have this can be one end, this can be one end, and this can himself can be one end, so I will increment answer 3 over here. So our answer comes out to be 6. Now this is similar to here where I similar to formula CNT minus 1 up to 1. So you can do both these logics, and this is the code. So first I'm just incrementing counter, and that counter I'm adding it to our original answer, and I will just return answer at the end. So this was second question, pretty simple. Now we'll move to third question, and this was also on easier side. So let's just read the problem statement first. So what we are given? We are given a string word and an integer k, and we are uh, given a condition for a string to be called as k special if the difference between frequency of every character is less than equal to k. So that is the simplified version of condition, because here they are given that frequency of word of I and frequency of word of j is less than equal to k. So basically it means the number of characters, difference between characters, frequency of characters present in that string should be less than equal to k. For example, here we can say let's have a string of length string AAB, and if we have a k equal to 1, then the frequency of A is 2, frequency of B is 1. So this satisfies our condition because the absolute difference between 2 and 1 is 1, and which is less than equal to k. So this satisfies our condition. So we are given a string and we can delete some characters from it such that we have to make our string case special. For example, in first case, AA, BCA and BA. Yes. So in the string, if we delete this C and if we delete this A and this A, our string comes out to be ABAB. Now here we deleted 3 elements and now we have this string, and if we calculate this frequency of for each character, frequency of A in this is 2, similarly frequency of B in this is 2, and if we calculate the absolute difference, it is less than equal to 2, and our k here is 2. So we found a string which is k special, and we cannot perform any type of any less number of operations. Here we did 3. If we do 2, we cannot find a k special string, so here answer was 3. Similarly in second case, you can read this and find that answer here is 2. Similarly here is 1. Now we are given a string of length 10 is to 5 and k here is again 10 is to 5. So our answer should be uh, linear complexity, means n square cannot work. Now here key observation is that we have a let's say we have characters, we have frequencies like 3, 4, 5, 6. So these are frequencies of characters, let's say A, B, C. These characters can be in any order, nothing matters. And let's say k here was 2. Now it is always optimal to fix one of the sides of uh, a range, because if k equal to 2, we have a range such that we can take all the frequencies from C and T to C and T plus k. Because if we take frequency of in elements which have frequency in this range, the absolute difference between any pair of frequency of characters will always be less than equal to k. So if we fix this, the minimum frequency of character, we can say that we have a range of frequencies. So 3, 4, 5 satisfies our frequency range, but for 6, if I remove one of the occurrences of that character, one of the occurrence of D. This will reduce to 5. Now for our frequency map will look like this: 3 4 5 5, and all the elements which are uh, all the characters satisfy our condition, and we can say that this is a case special string. This can form a case special string. So basically we are working with a frequency map. We don't need order of our string. So and key observation was here was to fix the minimum occurrence, and on basis of minimum occurrence get a range, and for that range find answer and check this answer for multiple ranges. So let's try to understand the code. So what I did here is I mapped all the characters, frequency of all the characters. Now I am pushing the minimum, pushing all the, what I can say, pushing all the frequencies in a vector. So I'm trying to create this kind of vector 3 4 5 6. So I pushed all the frequencies in A and I sorted that A. Now for I have, let's say, a frequency map like this, and K here was 2. Now I will find all the all uh, required number of our delete operations when I fix this 3 as my minimum frequency. So here if I fix this 3, this range is already case special, but I need to subtract 1 from this. So for if we fix uh, 3, our answer comes out to be 1. Now if we fix this 4, now 4 is minimum frequency, so this range will satisfy our case special. So if we fix 4, we don't need any operation on right side, but if we are fixing 4 as minimum, this 3 should be removed. So here answer is 3, because if we kept this 3 and 6 will not satisfy. So and similarly if we fix 5, answer will be 7. Similarly if we fix 6, answer will be all the elements which are less than, so 12, 5 plus 4 plus 3. So we have to check for each element, fixing the minimum frequency, and uh, check for all elements. And now we can do this by a 26 into 26 for n square for loop, because the vector size will maximum be 26, because we are just pushing the frequency of each character, and in lowercase English letter there will be only 26 letters. Now there must be a question where you might think that it is always optimal to fix the uh, minimum frequency element. So here if we fix 3, we always get the optimal answer, but that's not the case. If you just handle this solution on first sample test case, you will find a different solution, and you will understand the proof that we need to check all the frequencies to find the optimal answer. So if we try to understand code, this is just frequency mapping and then pushing that map frequencies in a vector. Then I sorted the vector. I declared two variables, sum and answer, as int max. So sum is basically the sum of elements before I, which means the elements which has lesser frequency than the minimum frequency which we have fixed. Then we have to remove all that sum. So for that I have declared a sum, but I could have just used another and for loop. The overall complexity would have been just n square still. Then I have declared a current vector. So I am iterating from on the right side of I. So all the elements which are greater than AI will be on the right side. So I just need to iterate from in the right side and check if the AJ is greater than A of I plus K. So for 3, the elements which are out of range will be greater than 5. So 3 plus 2 5 and 6 is one of the case, and if it is there, I will just add A of j minus A of I plus K from it, and finally take minimum of answer with current plus sum. Sum is the elements which has the frequency of elements which are lesser than current element, and current is just the elements on the right side which do not coincide in our range. And I will just update sum after each iteration, and finally I will just return answer. So this was also pretty simple question. 5000 students solved it, and this D suddenly difficulty increased from C to D. So definitely it was an unbalanced contest, and I tried to solve the solution as you can see, but I couldn't do it. So I will solve it, and I guess that's it from my side. Thank you for watching.